Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of August 19th this time around. It's a week where the moon starts very nearly full, ends at about 50% full, so it will be waning away. What that means is the moon is up pretty much all night long to start the week, and will be washing out a lot of things. But by the end of the week, it's not rising until midnight or after midnight, and so there's going to be some time in the evening to observe other things without moon interference. If we think back, some of the stuff we've been talking about last week, Mars and Jupiter were right on top of each other, and so we had some decent clear skies. I actually got to see it at its closest, the two planets at their closest approach to one another, and now they're separating out. And by the end of the week ahead, Mars is going to be a full 6 degrees, more than half a fist width at arm's length east of Jupiter. So you can really see how much faster Mars is moving against the background stars than is Jupiter. That space is really growing as the week plays out. As the moon fades away on the 20th into the 21st, so the evening of the 20th into the morning of the 21st, just past full. It's going to look pretty full to you, the moon still. The moon gets really close to Saturn, and for some people, the moon will actually occult Saturn. This is impressive to see the moon block the light from something so bright as Saturn. Where I am in the middle of the United States, I'm just going to see these things get really close to one another in the evening of the 20th. Just before midnight, those things will be really close. All night long, the moon's going to be really close to Saturn. Now, from South America, the northern part of South America, through North Africa, up into the western part of Europe, there will be an actual occultation. So, for example, if you're watching this from Great Britain, then you might see the moon occult Saturn starting somewhere in the neighborhood of 4:30 in the morning, I think, for you, and ending about 5:15 in the morning on the morning of the 21st. So that's something to watch for if you're in the northern South America or North Africa or the western part of Europe. You might be able to see an actual occultation. For everybody, it's going to be great. The moon's going to be nearly full moon near Saturn. 4 nights later, the moon's down to 50% full, and it's near the Pleiades star cluster. That's faint enough. 50% full, it won't wash it out. So that'll be a nice pairing to watch the moon next to the Pleiades star cluster. Probably best the morning of the 25th, just after midnight sometime, as you see the moon fade away there in Taurus. Okay, good. So that's all good stuff. As it's later in the week, and the moon's rising later, you have a chance to observe some things just after sunset. So what we want to go out and look at is, let's start with Aquila. The Altair is the third star of the summer triangle. It's the southernmost star of the summer triangle. And it's the brightest star in Aquila, the eagle here. And what I see primarily when I see this constellation is a flattened diamond. It looks like a kite or a stingray. And it has a tail that drags out this direction. And I'm often, when I draw it on the board, when I see it in the night sky, I don't pay any attention to Lambda, this star that's pulling the tail down here. So the stars are Altair is the bright star, the alpha star. And then you've got Zeta and Theta marking the corners over here, and Delta, the base of this diamond shape. And Lambda is dropping down here. You've got a couple of other stars. And then you drop over to a star over here that's a 4.2 magnitude star, and a star here that's a 3.9 magnitude star. So these are both about 4th magnitude stars, pretty easily visible if you've got any kind of dark skies at all. So not bright by any stretch of the imagination, fainter than what we're looking at up here, but easy enough to see if you've got reasonably dark skies. The alpha and beta stars in Scutum are the two stars we're looking at here. So if you've never done this before, it's a good week to go out high in the sky. It gets dark, for me, about 9:30 p.m. So we're good and solid dark now as the sun's setting earlier. We see this at about 9:30 p.m. It's going to be on the meridian, that north-south line that connects Earth. So it's about as high in the sky as it gets. Portions of that will be there earlier, and portions of it will be there later, so 9 o'clock, something like that. So just after dark, really well placed for observing. So you go out, if you've never done this, if you've never found the other stars of Aquila, go ahead and do that. And if you've never identified Scutum as a constellation, which I don't do very much, you got these faint stars, right? It's worth going out and taking a look at. Now, one of the things about this is that just to the east of Beta, so we're just talking about a couple of degrees hop over here, is M11. M11 is probably the best open star cluster for my money. It's the best open star cluster you can look at in a small telescope. So if you have, you'll see it with binoculars. You might even be able to see it with your naked eye if you got really good dark skies. But binoculars are going to show this, and the small telescope is just going to explode into a glittering pattern of stars. Just a bunch of stars in the field of view right there. It's just absolutely fabulous. I'll give it 2 check marks right there. Go double check. Go check that out if you get a chance. Now there's another open star cluster about the same distance, a little further from Alpha and down to the south and east of Alpha. And this was south and east of Beta, was M11, is M26. M26 is a fine open star cluster. It only seems less fabulous by comparison to M11, but that's going to look good to you as well. So that's our main targets here this week as we watch that Saturn and the Moon. And those of you who are located in a fortunate enough place to see the actual occultation, that's great. But for the evening sky, let's see if we can find M11 and M26 after identifying the stars of Aquila and the 2 brightest stars in Scutum. But let's go on and do one more thing. There are a couple of interesting stars nearby here that we can go ahead and find. And right next to M26, less than a degree to the north and west of M26 is Delta. And it's a 5th magnitude star. It's down about 4.7 magnitude, right at the edge of naked eye visibility. And so you can take a look at that. And if you want to, what I recommend is spending an evening, if you've got a telescope in particular, get a telescope that shows you a whole bunch of stars in this region that you can compare the brightness of this star to and see if you can tell that it is changing brightness. It is the prototype. We name variable stars. So most stars live their lives happily for most of their lives. They live happily with gravitational pressure pushing inward and thermal pressure, that's either gas pressure or radiation pressure, or a combination of both, pushing outward. And so they're balanced. They don't collapse, they don't expand. But you can get a point where you can pull that. So imagine a swing that's sitting down at like this, and a pendulum, and you pull it back and it swings back and forth. Most stars, you tweak them away from equilibrium. You give them a perturbation in the language of astrophysicists or mathematicians. So you perturb them away from equilibrium, and they just damp out and go right back. And we've all seen this with over-damped systems. We call those over-damped systems, where if you have a piston and you pull it out, you pull out a plunger and on a spring, and it wants to go back, but you got really stiff fluid in there, it just goes right back, it sits right back down. That's what most stars do. But some stars get the right point of kick of energy. If you have a person on a swing and you push them at the right time, they can keep swinging back and forth, and they'll oscillate. And Delta is one of those stars, and it's the prototype of a class of variable stars called Delta Scuti stars. So Delta Scuti stars are really interesting. We've got a couple of them in one of the fields of views that we study. We just love playing with those because they oscillate with very small amplitude. So if you watch this star to see if you can tell if it's changing brightness, it's only going to change brightness by about 15%. So it's not very dramatic at all. It's something you're going to have to work at. But some things that are fun, you have to work at them, right? And so, but the great thing about it is it's got periods. All Delta Scuti stars have periods that are on the order of hours, sometimes even less than an hour, where they oscillate back and forth. But they often have multiple oscillation modes, sometimes as many as 8 or 10 or 12, just a whole bunch of modes. So it's not just one period up and down, but it's a whole bunch of interacting periods like that. So the brightness can be a little bit chaotic. You can see these different periods going up and down. And so that's a fun star because that's the prototype of that class of stars. There's a better variable star, R, that's up here by M11, about the same distance away. R is an RV Tau star. And RV Tau stars, they aren't all that common, but they've got big amplitudes of variation, and they typically look something like this. If you plot the brightness versus time, you got something that looks like that, and a small minimum followed by a big minimum, right? And so you get small minimum, big minimum. There's usually not that flat, not that much space. But anyway, small minimum, big minimum, small minimum, big minimum. Our Scuti is a little bit funny, and it's more chaotic than a lot of RV Tau stars. But it will change by a factor of maybe as much as 10 in brightness when it goes from up here to down here in these minima. So you can watch that. I forget what the period of RV Tau is. I think it's probably something on the order of 170 days, so it's like half a year. So you got to watch that one for a while to see that one going. But it's a more interesting star in that it's right on the edge of naked eye visibility and then not. when it gets down in here, when it gets pretty faint like that. So a couple of interesting variable stars just to know, just to look at and say, yeah, you've seen them. But if you want a project, try to watch them and see if you can see them getting dimmer. Two really good open star clusters. Some stars maybe you haven't paid attention to in that region. Remember the moon is near Saturn early in the week this week. And that's what we got for you. As always, everybody, thanks for watching, and we hope you have a great observing week in the week ahead.